All right, Algebra 2, welcome back, guys. So we are officially starting Section 6 today of Chapter 5. All right, and we are doing the oh-so-famous quadratic formula. Yes, I get it. That's a little bit of a geek moment there for a math teacher, but in the world of math formulas, this is pretty much at the top of that list, all right? So as you can see it right there on your screen, that is the quadratic formula. Copy it down, memorize it. You should pretty much already have this memorized, but if we're not there yet, take it in your notes, memorize it, and now we're going to have to get used to using it. All right. So here we go. All right, famous quadratic formula. Yes, yes, yes. This is also something that you could use on pretty much every single trinomial. You can even use it on a binomial, but you would have to manipulate the binomial just a little bit. But this would work every single time. All right, this is going to work for real roots or imaginary roots, complex roots, all of that. Okay, and as you can see on your screen right there, the ax squared plus bx plus c, that is that's the standard form of a trinomial. Okay, and so when it's in that format, it's very simple to understand that you got your a, your b, your c, because if you look back up, those are the variables that we're using there. We're filling in the blanks of a, b, and c with the values that were given in the standard form. Okay, and then let's take another look right down here. All right, so if you don't have a value for a or b, then you're going to fill in that blank with the number 1. If you don't have a value for c, then you are filling in that blank with a 0. All right, so it's important to understand and distinguish between those two things right there. All right, the next thing we're going to be talking about here is the discriminant. This is going to be one of the terms that they use throughout this section. And so we're talking about this guy right here. That word, the discriminant, is this equation right here. But that actually, if you look, we go back up to the quadratic formula, that is the part that's underneath the radical. But you will notice the discriminant does not use the radical. So if they say use the discriminant to figure out how many roots, not what are those roots, just how many roots, then you will use that right there, b squared minus 4ac, but not with the square root. All right, again, not with the radical. Okay, all right, so there you go. Copy that chart on page 358. That's the discriminant chart. It's going to give you a little bit more details. And then again, if you look a couple pages over on 360, this summarizes every different methodology. In other words, every different style to solve for a binomial or a trinomial, basically polynomials in general. Okay, so if you can understand, if not copy, all right, that chart, that's going to give you every different option, whether we're solving using square roots or completing the square or factoring or using the quadratic formula. Those are all the different ways that you can solve these types of problems. All right, so here we go. Let's jump into the example problems. Solve for the zeros, find the zeros. That's the same way as basically to say solve it, find the roots. Okay, so let's fill in some of the blanks here. We don't have a value for A, so we know that that's 1. There's our value for B, and there's our value right there for C as -7. Okay, so we're going to have a negative B, which B is given as a positive, but negative B, okay, plus or minus the square root of B squared minus, and then I like to put all of these guys in parentheses because they will all be multiplied with each other. So you got b squared minus 4 multiplied by a, which is 1, multiplied by c, which is -7. And then all of that is divided by 2 times a, which in this case is simply 1. All right, now pull out that calculator. All right, don't worry about wasting time trying to do all this stuff in your head. Okay, if you make a simple error, that's what's going to wreck all of this. Okay, so let's do all of that stuff underneath the radical. Okay, so we have a 3 squared minus a 4 times a 1 And then that is a -7. Okay, plug all of that into the calculator, and I get a 37. So what do we have here? We have a -3 plus or minus the square root of 37, all divided by 2. And if we're looking at this, the square root of 37 can't go anywhere. All right, in other words, what would it help us to break 37 down? It's not going to break down into anything. Okay, the 2 on the bottom can't be going anywhere, and that -3 doesn't help us. 3 over 2 can't even be simplified. So, perfect. We just solved that problem right there. That's the answer to number 1. Okay. All right, let's go in. Let's take a look at number 2. Again, we have an A value of 1. Our B value is -8. Our C value is 10. So let's set the whole equation up. Remember, it's negative B. But if B is a negative given in the equation, then it's going to go back and be a positive. So we're looking at now 8 plus or minus the square root of B squared, which -8 squared is the same thing as 8 squared. So I'll be honest, if you just put 8 squared in there, you're still going to get the same answer, because anytime you square something, it's always a positive. All right, minus, and then let's put our parentheses just so we understand that everything's multiplied. 4 times A times C, and all of this is divided, in this case, simply by 2, because 2 times 1 is going to be 2. All right, let's plug this into the calculator. So we are going to have 8 squared minus 4 times a 1 times a 10. And I'm getting a positive 24 out of that. So we have 8 plus or minus the square root of 24, all divided by 2. Okay, now the square root of 24, that can go somewhere. All right, we can actually take that square root of 24 and break that down into 2 other possible factors here. So let's think what the best options might be. Let's see, if we did 12 and 2, or we could do 8 and 4. Let's try that. Okay, so we have 8, we have 4. 8 can go one more time and be a 4 and a 2. Okay, now that becomes 2. That becomes 2. And these numbers right here, 2 and 2, would make a 4 with a radical 2. So now what I'm going to do, let's simplify, put all of this stuff down here. And we have 8 plus or minus a 4 radical 2, all divided by 2. Now this is important that you see this, because what you should notice here is that the number 8, the number 4, and the number 2 are all divisible by the number 2. Now the next thing is that you have to have all 3 parts. You have to have that number in front of the plus or minus, the number on the right side of the plus or minus, and the denominator on the bottom. All 3 parts divisible by the same thing, which in this case is the number 2. So let's simplify that. So 2 will drop out, 4 will become 2, and 8 will become 4, leaving us with, you know what, actually I just realized here, there was a mistake. 8 times 4 is not 24. That's all on me. I'm sorry. I'm sure you guys watching this video immediately noticed Mr. A made that little mistake right there. So let's go back. That's going to change this up right there. And that's going to change this part up right here. So that's okay. We will catch up. This should have been a radical 3. That makes, of course, a lot more sense. So that's going to change one other thing down here. Let's do this. All right. And it's going to change that 2 right there, isn't it? Okay. All right, my apologies, guys. Of course, you I'm sure those that are watching this video are thinking, great, he's wasting more time now, but I'm going to get right back to it. So that radical 3 can't go anywhere. The 8 still became radical 4, radical 2, leaving us with a radical 2. But this is now the piece we should see. You have a radical 2 and a radical 3, which actually makes a radical 6. So here's what we're writing down here. 2 radical 6. And now, just to make things nice and the same, the number 2 still worked. All right, so we're going to cross out that 2, the 2 on the bottom, and the 8 still became 4. So all of this now would become a 4 plus or minus radical 6. That would be the proper final answer right there. All right, my apologies, guys, but I found the error. We correct it. We move on. All right, let's take a look at number 3 here. So we, again, are going to use the quadratic, but this is going to be a good example because now we're going to use imaginary numbers. Follow me through this one. All right, so here is A. B, in this case, is a 1, and here's C. All right, so let's write this out. You have a negative B, so that turns that 1 to a positive, plus or minus big square root of B squared minus, and let's fill in all of our parentheses, 4. What is A? 3. What is C? 8. All divided by 2A. All right, so let's plug all this into the calculator here. We have a 1 squared minus a 4 times a 3 times an 8. And here comes our imaginary number. So we're going to look at this as a 1 plus or minus the square root of a negative 95 all over 6. So that negative 95, we are now going to have to take out that negative sign. And how do we do that? We do that by taking I out, the lowercase I. So this one, I can give you the heads up on this. It's kind of nice. The 95, breaking it down, won't help us. So that saves us a lot of time. So what we're actually looking at is just a 1 plus or minus the square root of 95. Then we put I right over there, all over 6. That is what we got. Okay, so if you don't pull that negative sign out, which would be the lowercase I, then that one's not going to work out. It's not going to be correct. Okay, let's move on to our last 2 example problems here. We're getting the discriminant, and remember, the discriminant is just the b squared minus 4ac. No square root, nothing else involved with it. So let's take this negative 4, move it over here. We have x squared minus 4x plus 4. All right, so our a is 1, our b is negative 4, and our c is a positive 4. So we have negative 4 squared minus, fill in our parentheses, 4. What's a? It's 1. What is c? It's 4. So simply plug this directly into the calculator. You have a 4 squared. Remember, negative 4, positive 4, still going to equal a positive number when you square it. Minus a 4 multiplied by a 1 multiplied by a 4. And what do we get here? Let's see. We actually get 0. So now take a look at that chart on the very top of page 358 that I hope you copied into your notes. If you have your discriminant of 0, that means you have 1 solution. Okay, so 1 distinct solution. I need to know that, and I need to know that right there. All right, let's do part B. Again, let's take this value, bring it over here. X squared minus 4x now plus 8. Okay. Our a value is 1, our b value is negative 4, and our c value is a positive 8. So we have b squared minus 4 times A times C. All right, plug that directly into the calculator there. Let's see, we got 4 squared minus a 4 times a 1 times an 8. And what do we get? Let's see. We get negative 16, it looks like. All right. So negative 16. Now take a look back at that chart. If you ever have a negative value for the discriminant, what is that going to give you? That's going to give you essentially 2 non-real numbers. Okay, and the way the book describes it, non-real complex solution. So I need to know this right here, as well as this right here. All right, that was our last example problem. That covers us for section 6, the quadratic formula. All right, have a good one, guys. I'll see you in the next one.